All right, guys, this is 2008, number 3, and you have a TI for this one. Hopefully you've already read the problem and you've pulled out your given information. The volume increases at a constant rate of 2,000 cubic centimeters per minute. So hopefully you pulled out dV/dt, and that's positive because it's increasing. The oil slick forms a right circular cylinder. Radius and height are changing with time, and then they gave you the formula there, so that's nice. Part A, at the instant when the radius is 100 centimeters and the height is 0.5 centimeters, the radius is increasing at the rate of 2.5 centimeters per minute. At the instant, what is the rate of change of the height of the oil slick? Here we go. Lots of information here. dV/dt was given to us in the first initial paragraph. The formula was given to us in the paragraph. This is the information I pulled out of part A. The radius is 100 when the height is 0.5, and at that instant, dr/dt is 2.5 centimeters per minute, and we're trying to find dH/dt. So, based on all that given information, I can leave my formula alone, and I'm just going to find the derivative. Now, what you have to realize, you want to look at this as the product rule. Pi r squared times h. So that's your high and that's your ho. So when you do your product rule, dV/dt equals pi r squared dH/dt, high d ho plus ho d high. And there's your derivative, okay? Now you just sub in all of your given information and solve. And you should get, and make sure you round correctly, dH/dt equals 0.039. Check that on your calculator. You want to make sure you know how to calculate all this with your TI. Okay, so that's part A. Part B says that a recovery device arrives on the scene and begins removing oil. And the rate at which the oil is removed is R of T. Okay, and this is centimeters per minute as well. Let's see here. Oil continues to leak at the rate of 2,000 centimeters per minute, and we want to find the time when it reaches a max. So if we think back to our max, the oil is a max when its derivative is 0 or d and e and has a sign change of plus to minus. Now, if you recall, I want to add up all the oil that's going in and subtract all the oil going out, which is being removed. So if I'm adding all that up, I would integrate it, but if I take the derivative, it's just in minus out. So 2,000 is the rate that the oil is going into the lake, and R of T is the rate that it's being removed. So when does that equal 0? Set them equal, solve for T, and to have a max, you want to make sure you have a sign change, plus to minus, which we do. Therefore, the oil is a max when T equals 25 minutes. Awesome. Last part. By the time the recovery device began removing oil, 6,000 cubic centimeters had already leaked. Write, but do not evaluate an expression involving an integral that gives the volume of the oil at that point, at that time. Okay, so here we go. By the time the recovery device arrives, 6,000 cubic centimeters had already leaked in. That is your initial amount, okay? So the volume is equal to 60,000 plus, I need to add up, integrate all the oil that's going into the lake, that's the rate it's going in, and I'm subtracting the rate at which it's being removed. And I'm finding the volume at the time we found in part B. So my limit is 0 to 25. 25 is the time that we found in part B. So my answer from part B becomes that upper limit. And you just have to write the integral. You don't have to solve it. So that's it. All done.